In lessons 4, parts C and D, we're going to look at analyzing graphs. You can see our first graph here shows the average household income, and this was for $2009 versus year. Notice we want to pay attention to how things are labeled. The vertical axis is the average household income. And then, of course, along the bottom, we have the years from 1999 through 2009. It says, with just a quick glance, what does this graph tell you about the average household income? Well, you can see that it varied, and if we look really closely, we can see that the highest it ever was in $2009 was back in 1999, where it was between $52,000 and $53,000. The lowest actually occurred in 2009, where it's a little less than $50,000. It says a period of growth in income occurred between which 2 years? Does it seem like a lot of growth? Well, if we look at the graph, we can see that the 2-year period, let's see, we started growing in 2004, and it actually kept growing until 2007. I would say that that's a period of growth between, between which 2 years? Okay, so over a 3-year period. So from 2004 to 2007. That's the question, does it seem like a lot of growth? Well, in 2004, it was a little over 50,000, right about here. So I'm going to say maybe 50,200, something like that. And by 2000, it looks like it had reached 52,000. I'm not really sure if I would call that a lot of growth. It's about $1,800, which certainly is meaningful. All right, objectives for the lesson. You will understand that the construction of a graph can change your perception of the information it represents. That's a really important idea. A lot of what people think about graphs has to do with how the graph was made, what type of graph they used. And we want to be able to calculate absolute and relative change from a line graph. So we'll talk about the difference between an absolute change and a relative change. Question 3 says, now let's look at graph 2. With just a quick glance, what does this tell you about average household income? Notice this is an average household income for the same period of time. But all of a sudden, it looks like household income was fairly stable, and I think that's a valid statement. Household income was stable from 1999 to 2009. Doesn't mean it didn't change at all. We can still see small changes, but it doesn't look like it changed nearly as much as it did in that earlier graph. Let's look at that and let's think about why that other graph looked so much more volatile. Here's the first graph we saw. Here's the second graph. Here's the really significant thing. It happens right here. Graph 1 had a break in the graph. Notice how they put the little wavy lines between 0 and 48,000? They're basically saying we're skipping over all of the numbers from 0 to 47,000. So this graph really only went from 48,000 to about 53,000. This graph, however, covered the entire range from 0 to 60,000. If we go here, the graph 1 started right about here. Whoops. Sorry. So graph 1 only went from 48,000 to 53. Well, 53 would be about right here. It's like they took that part of the graph from here to here, and they blew it up great big. Well, if you blow it up great big, if you look, you can see those small fluctuations. Graph 1 makes small fluctuations in household income look much larger. By starting here at 0, you get a more realistic picture of what a small change that really was. What is the key difference in the graphs? How does this affect the visual impression made by each graph? Well, we already found the key difference, and the key difference is the vertical axis is different. And the most significant, of course, is this point right here where they've skipped over all of the dollar amounts from 0 to 48,000. Okay. Obviously, when you look at graph 1, it looks like household income varies a lot, that it was really up and down. When you look at graph 2, you realize, it looks really stable. So I'd say those were the big differences. A lot of times the media wants you to think something's more dramatic than it is. This makes it look like we have dramatic changes, and this one makes it look very stable. Says who might want to publish graph 1 in the newspaper? Who might want to publish graph 2? Well, politicians love information. If you are running a political campaign and you're a newcomer, you might want to publish graph 1 to point out how there was a long period that currently, look at this, from 2000 to 2009, that household income is down. You might really want to emphasize the point that household income is down. On the other hand, if you're already in office, you're the incumbent and you're trying to run for re-election, you're not going to want to point out that household incomes are down. You might want to point out the fact that the household incomes have remained relatively stable during a difficult economic time. So it really depends on the message you're trying to get across. You want people to think there's a lot of change? This graph looks like there's a lot of change. You want people to think that household income hasn't changed? The second graph looks pretty stable. Okay. You saw how the visual impression made by the graphs was deceptive. This is why it's good to think about the actual data presented in graphs. One way to decide if there's a lot of change is to calculate the relative change. Okay, we need to know how to calculate relative change. Let's go ahead and talk about absolute change as well. Absolute change is just a straightforward difference. It's just the ending amount minus the beginning amount. If you make $42,000 a year now, and you used to make $40,000, that's an absolute change of $2,000. Your income increased $2,000, okay? Relative change is usually a percent. Anytime something's relative, it means you're comparing it to something else. Relative change is the absolute change. So let's go the ending amount. I'm going to abbreviate amount minus the beginning amount divided by the beginning amount. You're comparing the amount of change to the amount you started with. And of course, after you get this will be a decimal. You can just multiply by 100 and that will make it a percent. Okay. So absolute change just tells you the amount of change. Relative change compares that amount, that absolute change, to the original or beginning amount. Oh, there's the formula we just wrote. In the previous assignment to 4C and D, and I hope you're looking at your workbook and you're looking at those previous assignments, relative change was defined as the ratio of the amount of change to the original amount. In that assignment, you calculated relative change over the entire period represented in this graph. Question 7. What was the relative change in income from 2004 to 2007? So there's 2004, there's 2007. Express the relative change rounded to the nearest 1/10 of a percentage point. Be sure your answer is labeled thoroughly in your notes. All right, so let's look at, we're going to need to get the income amounts for each of those years. 2004, if we follow this over, that looks to me to be approximately, and we have to estimate how far up it is. I'm going to say it's about 3/10. I'm going to say that's 50,300. In 2007, it looks to be right at 52,000. I estimated it a little different than I did earlier. Earlier, I think I said 50,200, but I think when I look, I think I like 300. So let's see if we can get the relative change. We're going to do the final amount minus the beginning amount over the beginning amount. So that's going to be 1,700 compared to 52,000. Now, if we stop here, we actually are going to get a decimal. 1,700 divided by 52,000. Comes out to be 0.0327. I'm going to round it a little bit. But remember, we were told we normally want to write this as a percent. So we're going to multiply it by 100 to make it a percent. That's going to move that decimal right here to the nearest 1/10. That is going to be not, we could say 3.27%, but remember this is the hundredths. I'm getting 3.3%. So that income increased by 3%, a little more than 3% during that period. The graph also shows a period of rapid decline in income. Determine the relative change in income for that period. Well, we have a very pronounced rapid decline in this single 1 year period here. So look at just that 1 year. In 2007, we see that the average household income is $52,000. And by 2008, that looks like it has dropped all the way to $50,000. Might be a hair over, but let's just say it dropped to 50,000. All right, in this case, if we want to get that relative change, sometimes it's called a percent change. We would do the final amount, it's 50,000, minus the beginning amount, 52,000, divided by the beginning amount, times 100. Notice this time it's going to be negative because the absolute change, which is that ending minus beginning, is a negative quantity, that absolute difference there. So we've got negative 2,000 divided by 52,000 times 100, and that came out to be a negative 3.8%. The negative indicating that we had a relative decrease, that it went down, did not go up. Just write a contextual sentence about your answer to question A. Refer to the resource Writing Principles if needed. Okay, let's think about what we might want to say. Let's go back and look at question A. We basically determined that there was a decrease in household income of about negative 3.8, or a decrease of 3.8% during that period. Contextual means we want to be very specific. So let's see what we might want to include. We want to include what we're talking about, household income. We know that when we went between, in this time period, we want to be very specific. What time are we talking about? What happened? Household income decreased by 3.8%. So our sentence might look something like this. Between 2007 and 2008, the average household income decreased by 3.8%. I think that's a pretty good sentence that gives us a lot of information about what we're talking about. All right, so now let's use our graphs to try to think about changes and how graphs can show change. Question 1, true or false? This pair of graphs predicts that the number of non-Hispanics in the United States is expected to decline between 2010 and 2050. So we can see when we look at the graph that in 2010, Hispanics represented 16% of the U.S. population and non-Hispanics represented 84%. By 2050, that's expected to change so that the percentage of Hispanic U.S. citizens is supposed to rise to 30%, and non-Hispanics will probably only represent 70%. Think about whether or not you think that means what this says. It says, this paragraph predicts that the number of non-Hispanics in the United States is expected to decline. Does this graph mean we'll have fewer non-Hispanic people? One thing I know is that the U.S. population is growing, and it has continued to grow. However, not all segments of the U.S. population are growing at the same rate. Hispanics represents probably the most rapidly growing portion of our population. If you think about it, it's possible for other groups, non-Hispanic whites, Black citizens, Asian American citizens, all of those to be increasing, but just not increasing as rapidly as the Hispanic population in the United States is increasing. I know the correct answer to this is in fact false. The fact that non-Hispanics will represent a smaller percentage does not mean there will be fewer non-Hispanics. Let's look at how we can do that, how we can see that. The US population in 2010 was about 310 million. In 2050, the population is expected to be around 439 million. Guys, that's a growth of 129 million people. Part A, estimate the number of Hispanic and non-Hispanic Americans for each of these years. All right, let's go back. In 2010, it was 16% Hispanic and 84% non-Hispanic. So let's do those first. 2010. We want 16% of 310. So if we do 16% of 310, we don't need to write out all those zeros, we can just say 310 million. That is the same as saying I need to multiply by 0.16. That means in 2010 we had 49.6 million Hispanic. And then if we want to do the non-Hispanic, that was the remaining 84%. Whoops. 84 times 310 million. 0.84 times 310. There were about 260.4 million, so lots of people, non-Hispanic people. All right, let's see how that's going to look when we get to 2050. In 2050, they're saying that the Hispanic population will be 30%. So 30% of how many people will there be? 439 million is the current estimate. So 30%, 0.30 times 439 0.30 times 439, that's 131.7 million Hispanic citizens. Notice that's a huge increase from 49.6 million to 131.7. That's more than double. It's close to tripling. Non-Hispanic will make up the other 70%. 0.70 times 439 million. 0.70 times 439 is 307.3 million non-Hispanic. Notice that the non-Hispanic group grew by 47 million. It's not a case that the non-Hispanics are not growing. It's simply a matter that the Hispanic group is growing at a bit faster rate. So this agrees with what I said earlier. When I made the prediction, let's go back, it asked, is the non-Hispanic population in the U.S. going to decline? And I said no. And if we look, we see that the non-Hispanic population increased. So it supports. We can look at the difference. I'm just going to abbreviate H, increased. How much? We can look at an absolute change. Absolute means just the final amount minus the beginning amount. The absolute change of 307.3 minus 260.4. That's 46. Whoops, I wrote down that's supposed to, that's a 6. 260.4. That's an absolute change of 46.9 million. That's an increase. If we look strictly what happened with the Hispanic population, they also increased. They had an absolute change of 131.7 minus 49.6. For 82.1 million change there. This was in millions. This is also obviously an increase. So sometimes to really understand what a graph means, it's not enough to look at the percents. Yes, as a percentage, there will be a greater percentage of Hispanic Americans in 2050. But that doesn't mean there's going to be less non-Hispanic. There will in fact be more of both groups. All right, so let's move forward. We want to know that for some graphs, the base value must be known. That's particularly important with pie charts, which is what we just looked at. We want to be able to estimate the absolute size of the portions of a pie chart if given the base value, and use data displayed on two graphs to estimate a third quantity. It says, one newscast reported that the Hispanic population is expected to grow by 14% by 2050. Another station reported that it's expected to grow by 165%. Which report is correct, or are both correct, or neither correct? Well, let's see. Let's go back and get our numbers. We need to know the actual numbers for 2010 and the number for 2050, that prediction. We just found that. In 2010, there were 49.6. We're expecting that to increase to 131.7. So 49.6 and 131.7. Remember, those are a million people. All right. I want to talk about the correct way. We can see that the change in the two is different. It went from 16% to 30%. That is not an increase in the population of 14%. The correct way to say that would be to say the percent of Hispanic Americans will increase 14 percentage points. Or a lot of times I won't put that in, 14 points. In other words, it's really an absolute change in the percent. The percent of Hispanic Americans will increase 14 points or 14 percentage points. Either way would be fine to say that. That's not actually telling us about the number of citizens. If we want to know what the percentage changes for the Hispanic population, we need to go back and do the actual numbers and do a relative change. So the relative change is always the final amount minus the beginning amount. So 131.7 minus 49.6. Those are both in millions, so we can leave it that way. We can write the million if we want. Divided by the original amount of 49.6 million. Notice if we leave the millions, they're going to cancel out because they have the same units. Times 100%. If I do 131.7 minus 49.6, I get 82.1. So I have 82.1 over 49.6 times 100. And my calculator gives me 165.5%. So this one was definitely the better statement. The actual population growth is 165%. When you're looking at the entire United States population, that includes Hispanic and non-Hispanic, the percentage of Hispanic Americans will increase by 14 points. It will go from 16 percentage points to 30 percentage points. Question 3 illustrates an interesting twist to absolute and relative change. If your original quantities are given as percentages, then the absolute change should be expressed as a change in percentage points. That's what we did. We said the percent, try to write some good sentences, of Hispanic Americans will increase by 14 percentage points. That's an absolute change in the percentage. It's 30 percentage points minus 16 percentage points is 14 percentage points. Okay, that's kind of a common mistake that people made. The actual growth of the Hispanic population during that time period looks to be about 165%. Okay, let's apply what we know to the U.S. gross domestic product. Gross domestic product is the value of all goods and services produced in the country. The U.S. national debt is the money the federal government owes. This is different from the deficit. The deficit is the difference between how much money the U.S. owes and how much in any particular, how much money we borrow in a particular year compared to the amount of money that's coming in a particular year. It's the deficit is the difference between money being spent and money coming in. Okay, if you figure your household budget, if you make $50,000 a year, but you spend $52,000, you have a $2,000 deficit. Okay, you may still owe $100,000 on a mortgage on a home and $25,000 on a car. That's your debt. So the national debt is the money the government owes. Okay. Let's look at some information for using graphs. The first graph shows the U.S. national debt by year. You can see back in 1950, look at this side. This is trillions of dollars. So in 1950, the national debt was well below $1 trillion. 1 trillion would be right here. It wasn't even half of a trillion. In 1960, it was still below a half a trillion. In 1970, it looks like it was probably right at half a trillion dollars. By 1980, it's about 1 trillion. This looks to be a little over 3 trillion in 1990. By the year 2000, it's at about almost 5.5 trillion. And by 2010, that has climbed all the way to 13.5. I'm going to write those just because that's interesting. You can see there's 13, so we're halfway in the middle. There's 13.5. This is about 5.5. I'm just kind of rounding. This is a little bit over 3. It's about 3.25 probably. This is 1. This is about a half. And those others are even smaller. Just consider the statement. The 2010 national debt is way out of hand and has never been higher. Do you agree or disagree? Well, I have to agree that based on this graph, 2010 is the largest national debt that's shown. Certainly $13.5 trillion is a lot more than 5 trillion and way more than 1 trillion. So I guess the question is that's the absolute size of the national debt. Are there other things that we should consider besides the absolute size of this debt? The graph below shows the same information, but represents it as a percentage of the gross domestic product. Federal debt as a percentage of the gross domestic product from 1790 to 2035. Notice the last part is a projection. It's kind of a prediction. Now consider the statement again. The 2010 national debt is way out of hand and has never been higher. Do you still agree or disagree? If we look for 2010, and I don't know exactly where it is, let's see, that's about 16 years, that's about 2006, so 2010 is somewhere around here. I'm going to guess it's right there. I don't know exactly where 2010 is. It's high, but you can see that we have had times in our history where the national debt as a percentage of gross domestic product was even higher, particularly if you look at World War II. That meant during World War II, we had to borrow a lot of money. Okay. Another way of thinking about it is to think about a person. If a person makes $50,000 a year and they owe $10,000 in debt, that's a lot of debt. But if a person makes $1 million a year and they owe $10,000 in debt, that's not very much debt at all because they have so much money. Okay. So we can kind of think as your gross domestic product is almost like income. It's how much goods and services we're making in this country, whereas the debt is how much we're borrowing. We can see back in World War II, we had to borrow a lot of money. We borrowed a fair amount also during the Civil War and World War I, but not so bad. So I think it's still pretty high because we're not currently at war. It's not like it's higher than it was for the Civil War or World War I. Or maybe it's the same. Maybe 2010 is right here and it's real close to the same. But it's not nearly as dramatic as it was, say, during World War II. It makes a difference when you look at that amount of debt relative to the gross domestic product. Oh, and that concludes the video for today.